Hello students, welcome to a series of mathematics program for grade 10 and grade 11. The topic for today is matrices. This is the second lesson on matrices. So let us start. You will remember that in the previous lesson, you had learned how to display information in the form of a matrix of any order. You had also learned how to work with equal matrices and how to solve problems involving the calculation of the sum and difference of two matrices where possible and interpret the results. In today's lesson, you will learn how to calculate the product of a matrix and a scalar quantity, and how to find the product of two matrices. Now, what is a scalar? A scalar is just a number. So first, we will learn how to multiply a matrix by a scalar. So to multiply a matrix by a scalar, we simply have to multiply each and every element of the matrix by that scalar. Let us consider this example. So I have 4 times the column matrix minus 1, 5. This means that I will have to multiply each element in the matrix by 4. So I have 4 times negative 1 and 4 times 5, which will give me minus 4 and 20. So in general, K times the matrix A, B, C, D, where K is a scalar, will be equal to K times A, which is KA, K times B, KB, K times C, which is KC, and K times D, which is KD. We now consider this example. Evaluate part A, 5 times the matrix 2, 6, negative 1, negative 4. So this means that I need to multiply each element by 5, which will give me 10, 30, negative 5, and negative 20. Part B, 1/4 times 4 minus 20 minus 12 and 16. So again, I have to multiply each element by 1/4. This will give me 1, negative 5, negative 3, and 4. Next example. Given that P is equal to 5, negative 2, 1, 3, and Q equal to 6, negative 1, 0, 4, evaluate part A, 3P plus 2Q, part B, half Q minus 2P. So you have the two matrices P and Q, both are of order 2 by 2. Part A, 3P plus 2Q. So I need to multiply all the elements in matrix P by 3 and all the elements in matrix Q by 2. Simplifying, I will get 15 minus 6, 3, 9 for 3P. And for matrix 2Q, I get 12 minus 2, 0, 8. So, as mentioned earlier, we have 2 by 2 matrices. This means that addition is possible. I add the corresponding elements and I get 27 minus 8, 3, and 17. Part B now. Half Q minus 2P. So half times matrix Q minus 2 times matrix P. Simplifying will give me 3 negative half 0 2 minus 10 negative 4 2 6. We have 2 by 2 matrices, so subtraction is possible. Subtracting the corresponding elements, we obtain minus 7, 7 over 2, minus 2, minus 4. Next example, express as a single matrix, 3 into 1, 3 minus 2, 5, minus the matrix 4, 0, minus 1, 2. So first, I need to multiply all the elements in this matrix by 3 to get 3, 9, minus 6, 15, then minus the matrix 4, 0, negative 1, 2. So I will obtain as final answer negative 1, 9, negative 5, and 13. We now move on to multiplication of matrices. We can multiply two matrices if and only if the number of columns in the first matrix is equal to the number of rows in the second matrix. I repeat, we can only multiply if the number of columns in the first matrix is equal to the number of rows in the second matrix. Let us consider some examples. Part A. First, I need to find the order of the two matrices. So the first matrix is of order 1 by 2. The second matrix is of order 2 by 1. The number of columns in the first matrix is 2. The number of rows in the second matrix is 2. So this means they are equal. We are using this sentence here. These two are equal. So if they are equal, this means that we can multiply the two matrices. Now look at example B. The order of the first matrix is 2 by 3. The order of the second matrix is 1 by 2. Number of columns in first matrix is 3. Number of rows in second matrix is 1. So you can see here these two are not equal. If they are not equal, this means that we cannot multiply the two matrices. Now, suppose that we can multiply two matrices. What will be the order of the product matrix, of the resulting matrix? So when we multiply two matrices, the order of the resulting matrix is number of rows from the first matrix times by number of columns of the second matrix. I repeat, number of rows from the first matrix by number of columns of the second matrix. We consider an example. So first, I need to check whether multiplication of these two matrices is possible. The order of the first matrix is 1 by 2. The order of the second matrix is 2 by 1. So these two are equal. This means that we can multiply the two matrices. What would be the resulting order of the answer? It will be a 1 by 1. That is, I consider the number of rows from the first matrix by the number of columns of the second matrix. So the answer would be a 1 by 1 matrix. Part B, the order of the first matrix is a 2 by 2. The order of the second matrix is a 2 by 3. So these two are equal. This means that we can multiply the two matrices, and the order of the resulting matrix will be a 2 by 3. This is very important. You need to understand first whether we can multiply two matrices. Second, what would be the order of the resulting matrix. If you have understood these two concepts, then we can proceed to multiplication of matrices. So to multiply two matrices, we multiply the elements in the different rows in the first matrix with the elements in the columns in the second matrix. Let us consider an example. I need to evaluate this. First, I need to find the order of both matrices. So the first matrix is of order 1 by 3. The second matrix is of order 3 by 1. So these two are equal, so I can multiply. What would be the order of the resulting matrix? It will be a 1 by 1. Now I multiply the elements in the first row. Here I have only one row, by the elements in the first column. So I will get 3 times 1 plus 2 times 6 plus 5 times 4. Simplifying, this will give me 35. Remember, the answer is supposed to be a 1 by 1. A 1 by 1 matrix will have only one element. So I get 35. Second example, I need to evaluate this. So first step would be, can we perform multiplication? Can we multiply these two matrices? So first I need to find the order of both matrices. So here both matrices are of order 2 by 2. I check whether these two are equal. Yes. So I can multiply. And the resulting matrix will be of order 2 by 2. Now we move on to the actual multiplication. So I will multiply the first row by the first column. First row by first column. So I will have 1 times 4 plus 3 times 6. Next, I multiply the first row by the second column. First row, second column. So I will have 1 times negative 1 plus 3 times negative 5. Okay? We now move on to the second row. So I multiply the second row by the first column. Second row times first column. I will have 0 times 4 plus negative 2 times 6. So you can see this is where I'm going to place the answer. Finally, we multiply the second row by the second column. Second row times second column. So I will have 0 times negative 1 plus negative 2 times negative 5. And simplifying, I will obtain 22, negative 16, negative 12, and 10. This is a 2 by 2 matrix. And we had found in the first step that the resulting matrix will be a 2 by 2 matrix. We now move on to the third example. So first, I need to find out if matrix multiplication is possible. So I find the order of both matrices. The first one is of order 2 by 2. The second one is of order 2 by 3. So these two are equal. This means that we can multiply. And the resulting matrix will be of order 2 by 3. We now move on by multiplying the first row by the first column. First row, first column. So I will have 2 times -1 plus -3 times 2, which is -2, -6, -8. Now we multiply the first row by the second column. First row times second column. So I will have 2 times -2, 2 times -2 plus -3 times 4, which will give me -4 minus 12, which is equal to -16. Next, we multiply the first row by the third column. First row, third column. So I will have 2 times 6 plus -3 times 3. Simplifying, I will get 12 minus 9, which is 3. So the first row has been multiplied by all the columns. Now we proceed with the second row. I need to multiply the second row by the first column. I will get 1 times -1 plus 4 times 2. This will give me -1 plus 8, which is equal to 7. Next, we multiply the second row by the second column. Second row, second column. So I will get 1 times -2 plus 4 times 4. Simplifying, I will have -2 plus 16, which is 14. Finally, I multiply the second row by the third column. Second row, third column. So I will have 1 times 6 plus 4 times 3. And simplifying, I will have 6 plus 12, which is 18. So this is the final answer. I have a 2 by 3 matrix. 2 rows, 3 columns. Example 4. Teresa sells raspberries and black currants. The first matrix shows the number of kilograms of each fruit she sells during 3 different weeks. So this is the matrix. You have a number of kilograms of raspberries sold in the 3 weeks, the number of kilograms of black currants sold during the 3 weeks. The second matrix shows the price per kilogram in cents of the fruit Teresa sells. So here you have the price per kilogram, but remember it is in cents. So for raspberries, 650 cents per kilogram. For black currants, 580 cents per kilogram. First part, you're given these 2 matrices that we have seen in the question. So you have these 2 matrices. This is equal to D, and you need to find D. Second part, you need to explain the meaning of the information given by matrix D. And third part, you need to find the total amount in dollars that Teresa gets for the fruit she sells. So first part, I need to evaluate this product. So I have a 3 by 2 matrix times the second matrix is a 2 by 1. So multiplication is possible because I have two which are equal, and the resulting matrix will be of order 3 by 1. So remember, we need to take first row multiplied by first column. So I will have 3 times 650 plus 2 times 580. Next, I have second row times the column. 1.5 times 650 plus 3 times 580. And I will have a third row times the column. 2 times 650 plus 2.5 times 580. Simplifying, I will get first element 3,110, 2,715, 2,750. This is for the matrix D. The second part now, I need to explain what the elements in matrix D represent. So here, the elements obtained in matrix D represent the amount in cents for each week. So this will be the amount received for week 1. This is for week 1, week 2, and week 3. Third part, the total amount received by Teresa in dollars. Now remember, $1 is equal to 100 cents. So to convert this into dollars, if I have to convert these values into dollars, this means I will have to divide by 100. So to find the total amount, I just need to add the amount received in week 1 plus week 2 plus week 3, which gives me 8,575 cents. So converting this into dollars by dividing by 100, I will obtain 85.75 dollars. You now have a few questions to practice on matrix multiplication and multiplication of a matrix by a scalar. In these questions, you might also have to use what you have learned earlier regarding addition and subtraction. Now look at question 9, part B. You have been asked to find a square. So here you need to be careful. A square does not mean to square the different elements found in A. I repeat, a square is not 0 to the square, minus 2 to the square, 1 to the square, 3 to the square. That is, you just square the elements. A square means the matrix A times the matrix A. So you have to take matrix A, you multiply it by itself. Okay? You need to try this question. Here you also have A square as well. Question 14 and 15 are similar to the last example which we have just seen. So try to attempt question 14 as well as question 15. You also have two interesting links where you can get additional practice on what has just been explained to you. So students, in today's lesson, you have learned how to calculate the product of a matrix and a scalar quantity. You have also learned how to find the product of two matrices. I would advise you to attempt the questions found in this video as well as the questions found in your textbook. Remember, practice makes perfect. So you need to practice the questions so that you understand the different concepts. In case you have any difficulties, do not hesitate to contact your teacher, your friends, or even your parents. So until we meet again in the next video, it's goodbye from me. Thank you for your attention.